That's all good. But what if I don't have any odd power? What if it's only even powers? Well, even-powered integrals with even-powered sine or cosine. That's what's next. No odd powers. Well, it's different, obviously. So let's just do sine squared. The integral of sine squared x dx. So, matter of fact, this one is just sine squared. I don't even have cosine at all. So it really complicates if you get both of them. But anyway, don't have any sine to hold out because I only have even powers. So what I do when I have only even powers, and only an even power of sine or cosine, instead of using, we use the Pythagorean identity for when I had the odd powers. When you have the even powers, you're going to use the double angle. Which again, to rehash those, what were they? They were cosine squared x by a double angle is cosine squared equals 1/2. What was it? Cosine 2x plus 1. And sine squared is 1/2 cosine 2x minus 1. Yeah. We're going to use those instead. Yeah. Well, I'll give you the sheet. Yeah, they're on the sheet. Well, in a sense, this is really easier since it's just sine squared. It's just changing from this form to the double angle. Okay. Sine squared is 1/2 cosine 2x parentheses. And matter of fact, I mean, you can put the 1/2 where you want, but matter of fact, let's just go ahead and make it distribute the 1/2. 1/2 cosine 2x minus 1/2. That's usually easier to keep up with. Okay, so we just substitute. Instead of going sine squared is 1 minus cosine squared, we're going to use the double angle because it wouldn't get us anywhere to do just the Pythagorean anyway. However, notice this is now good. Did I write that right? I don't think I wrote that right. This. Yeah, okay. I've made a mistake here. That's what I had a minute ago, but I made a mistake then too. Okay. It goes the other way. I think that's what messed me up. I should have put this. It's 1 plus cosine 2x sine squared. So it's better to catch the mistake now before anybody gets hurt here. Okay. It's this, and it's right on the paper. So sorry about that. Need to rewind my tape and edit that out, huh? So it's 1/2 minus 1/2 cosine 2x. I had the minus, it's just in the wrong place. It's flip-flopped of what I had, okay? So please make that. It's right on the sheet, so you'll get it right on the paper. So, all right. But here's the thing then. This is then, I can split up these integrals, can't I? Since it's minus, I can do that. And the reason I split them up is because I can actually do this integral, the cosine 2x integral, by what? It's not a direct antiderivative, but a little simple substitution, right? A little u substitution. This one's just power rule. It's 1/2 times would be 1/2 times 1/2 x squared, right? And then this, just use a little u substitution again. U being 2x du is 2dx, and so du over 2 is my dx. So this will be the integral of 1/2 cosine of u du over 2. So you just wind up with another factor of 2 there on the bottom. So it's 1/4 x squared minus, that would be 1/4 derivative of cosine, integral of cosine, sine of u, but u was 2x plus c. So that's kind of what you have to do. Question? Oh. Where'd that x come from? I don't know. Yes, I did that wrong. That just be 1/2 x. Thank you. Yeah, this is not 1/2 x, it's just 1/2. So the antiderivative is 1/2 x. Maybe that's what I jumped the gun there. So it'll be 1/2 x. Strike 2 today. All right, so yeah, that's just 1/2. So it'll be the integral of 1/2, which is 1/2 x. Making sure you make that change. I think everything else I got right. Okay. Shall we do another? I guess so. What if I have the integral cosine squared 4y dy? Well, a couple of things here to contend with. First of all, I've only got an even power cosine. And so that tells me that I don't use the Pythagorean identity, I use the double angle. And I'll try to get that one right this time, okay? I'm going to use the double angle. The double angle, in this case, it's cosine squared. Cosine squared x equals 1/2 cosine 1 plus cosine 2x. I believe is the way I have it. Should have it listed there. All right. However, I have another thing, and that is I don't have cosine squared x. I have cosine squared 4y. I wouldn't go even to use substitution. Let's just substitute. All I have to do is substitute instead of x, I substitute for x, I substitute 4y. And so instead of 1 plus cosine 2x, it'll be 1 plus cosine 8y. Yeah, that's all I do. All right, so just make that substitution. I mean, it's not really a u sub. I don't have to go to the du stuff. So it's the integral. Cosine squared is 1/2 1 plus cosine of 2x, but the x is 4y, so it's 2 times 4y, which is 8y, and then dy. So it's I'd go ahead and do the 1/2 thing. So it's 1/2 plus 1/2 cosine 8y. And so then, it's just like previous. It's just really two integrals, 1/2 dy plus integral 1/2 cosine 8y dy. This is then where I would do, for this one, u substitution. This one, of course, is just 1/2 y. This is, u substitution, 8y. So du would be 8 dy divided by 8. Du over 8 is dy, so it'd be the integral of 1/2 cosine u du over 8. With me? So it is just 1/2 y plus the integral here. Well, I've got 1/16. The antiderivative of cosine is sine, so it'd be 1/16 sine of u plus c. But I'm not going to write that all over again because u is just 8y, so I'm going to put the 8y in there instead of u. What do you think? Bit confusing? Yeah. It's not as nice, neat as the other because you do have to do this little U substitution, but it's just a little U substitution. That's all it is after you change the double angle. Now what happens if I run into a higher even power? Question. Integral of cosine is sine. Yeah, it's the opposite of the derivative. Derivative of cosine is sine. Antiderivative of cosine is sine. Positive. Okay, this one's going to have an even power, but it's a higher. And no odd powers to save us either. Okay. Sine to the fourth x dx. Sine to the fourth x dx. All right. Well, it's only got even powers, and so I need to use the double angle. The double angle, though, only has sine squared option. So what I do here is really the same as I've kind of done this before. Interpret sine to the fourth as sine squared squared. So sine to the fourth is sine squared x squared dx. Then again, I'm going to substitute here the double angle, which I think I finally figured it out, is 1/2 1 minus cosine 2x. But then I've got to square that, dx. Yeah, this one's really going to get, yes, a little bit. Not too bad. You can do what you want to, but I probably should just go ahead and write the double angle as, that's usually the way you write it, but it's 1/2 minus 1/2 cosine 2x. Because that's really probably the way you should look at it. But guess what I have to do? I do have to square this out. One half minus 1/2 cosine 2x times 1/2 minus 1/2 cosine 2x. You got to square that thing out. And so that's going to be the integral, be 1/4 minus 1/4 cosine 2x minus 1/4 cosine 2x and plus 1/4 cosine squared 2x. dx. And the good news is these two are like, so I can combine them. Minus 1/4 minus 1/4. It's minus 1/2, isn't it? So I have 1/4 minus 1/2 cosine 2x plus 1/4 cosine squared 2x. All right, so here's where it kind of gets kind of crazy. Well, the good thing is these are all plus, so I can treat them individually. So I do the integral of 1/4 dx plus the integral, no, minus the integral 1/2 cosine 2x dx plus 1/4 integral 1/4 cosine squared 2x dx. Looking at that, two of the three are pretty easy. We've seen them before. This one, well, if you can't do that one, you shouldn't be in Calc 2, right? That's 1/4 x minus, and I guess you can't do that one, you shouldn't be in Calc 2 either. That one's u equals 2x. U substitution. So I get the integral of 1/2 cosine of u du over 2. With me? The third one, you talk about that one. What about that third one? What do you see about it on the third one? Uh-huh. Well, it's an even-powered cosine. So what am I going to have to do? I'm going to have to do this stuff again. Yeah. I'm going to have to use a double angle on this one, right? Because it's an even-powered cosine. So I'm going to have to use the double angle again. That's what I'm saying. It's kind of crazy. All right, so let's see. What would I do for cosine squared? Well, cosine squared x is 1/2 1 plus cosine 2x, and I would go ahead and just say it's 1/2 plus 1/2 cosine 2x. Let's cut to the chase there. Okay. However, this one's not cosine squared x, it's cosine squared 2x. So I'd put 2x instead of x, wouldn't I? Which would make this 4x. Okay, so it's 1/4. So this would be the integral of 1/4 cosine squared 2x. I'm going to make that substitution. It'll be 1/2 plus 1/2 cosine 4x dx. Now, maybe. Feels like we're going in circles, but spinning our wheels, but we're almost there. All right, so this is still 1/4 x. This one, we can do it now. It's minus 1/4. Antiderivative of cosine is sine. And u was 2x, so it'd be 1/4 sine of 2x. Pretty easily. This one, a little more work. The 1/4, yeah, well, you need to go ahead and multiply that in. So it'd be the integral of 1/8 plus 1/8 cosine 4x dx. Well, the integral of that's easy. So I'm going to get 1/4 x minus 1/4 sine of 2x plus, the integral of that's 1/8 x plus, what about this one? How am I going to do that? U sub, right? U sub. U equals 4x, du is 4 dx, so du over 4 is dx. So that would be 1/8 times 1/4 cosine of u, which would be sine of u, which in this case the u is 4x. So to save myself some steps, I'm just going to say it's 4. What? I just have to rewrite it anyway one more time. 1/4 x minus 1/4 sine 2x plus 1/8 x plus 1/32 sine of 4x plus c. Oh, yeah. Yeah, okay, yeah. Good. Yeah, there's a combination there. So I need to write it one more time. I should have done it right there. 1/4 x plus 1/8 x, you're right. Combine those. It's plus, isn't it? Be 5/8, because that's 4/8. It'll be 5/8 x. Oh, 2/8. I'm sorry. My bad. So 3/8 x minus 1/4. Strike 3, I'm out. Okay. Sine of 2x plus 1/32 sine of 4x plus c. There we go. Yeah. And you'll probably hate to see cosine 6 of x, right? Because that was just sine 4th of x, sine to the 6th. They get long. Okay.